Welcome back to Part 2 of Chapter 1, Introduction to Virtual Computing. In this section, we're going to take a look at virtualization products and categories in pages 12 through 19 of your text. So you may want to open your text to that page or your MindTap reader, and we'll get started. In this section, we're going to take a look at three categories of virtualization software products. First, Workstation Virtualization, which is used to allow you to run virtual machines on your desktop. Next, data center virtualization concepts and products. Today, most all data centers are using virtualization in various ways. And then, third, virtual desktop infrastructure, some concepts and products that we'll be studying in this course. Workstation virtualization products use Type 2 hypervisors. And as you may recall, Type 2 hypervisors are designed for creating and running virtual machines on top of an existing operating system, such as Windows, Macintosh, or Linux. Some of the benefits of workstation virtualization are described there on page 12. First, this provides a great way to run and test, learn about different desktop environments. You can install that environment right into a virtual machine as an alternative to having to install that on your hard drive and then having to reboot in order to run that other operating system. Another advantage of virtualization products are virtual appliances. Virtual appliances are software packages that include a virtual machine containing the pre-installed and configured applications all ready to use. You simply load the virtual machine onto your hypervisor and then you can run the application. Software developers often use workstation virtualization products such as VMware Workstation to test their products in different operating system versions and environments without having to actually install that operating system environment on their hard drive. System administrators can also use workstation virtualization products as configuration workbenches. And this allows the administrator to install, configure, and test servers and applications prior to actually deploying them in the production environment. Help desk support people can also use virtual machines. When they are talking to users about a problem, they can bring up the particular version of the operating system that user is having the problem with. And then classroom training. Oftentimes it's much easier for students to learn how to install and work with operating systems in a virtual machine environment than actually having to install them onto the hard drive of their lab computers. Some of the products we'll be taking a look at in this text is described in Table 1.1, page 13. VMware Workstation is covered in Chapter 3, both the professional version and the player version. Now, the professional version has a free download but requires licensing within 30 days. It has many advanced features and is typically used by software developers and in configuration workbench environments. VMware Player is a free version. There's also a paid version available. It runs existing virtual machines, lets you create virtual machines. It has some limited features, but it's great for running virtual appliances and just working with virtual machines on your home desktop. If you have Apple, then VMware has a product called Fusion. In Chapter 2, we'll be working with Oracle VirtualBox. This is a free product with many good features and support. It runs on Windows 7 or later versions of Windows. Microsoft has a Hyper-V client version that comes with Windows 8 Professional. And interestingly, Hyper-V is actually a Type 1 bare metal hypervisor. Even when you load it into your Windows environment on a system like Windows 8 or Windows 10. We'll be talking about Microsoft Hyper-V in Chapter 5. Virtualization is described on page 14 and 15 of your text. Almost all data centers today employ some type of virtualization. One of the original reasons for data center virtualization was to reduce what we call server sprawl. And server sprawl results from having multiple specialized servers in your data center. And over time, the number of these servers continues to increase until you have a lot more hardware costs as well as power consumption and cooling costs in the data center. This slide shows how virtualization of server can reduce server sprawl. Instead of having 4 physical computers, we can have 1 physical computer and 4 virtual machines, or perhaps a couple of physical servers in some type of cluster. Virtualizing server, along with other hyper-convergence technology, allows for the creation of software-defined data centers. We'll be talking more about these topics in Chapter 4. In addition to providing for power-saving costs and hardware costs by reducing server sprawl, data center virtualization also provides a centralized management for multiple servers, as well as other hardware devices. Instead of having special management councils for each device, a lot of these can be centralized into a single council. And as we mentioned in the previous slide, an important benefit of data center virtualization is server clustering. In this example, you see 3 different host computers all put into a cluster. And these clusters allow us to tie these computers into a central network hub and share data on some type of SAN storage device. Once this is accomplished, we can have virtual machines running on multiple hosts. So you might have 2 virtual machines on this host, 1 on this one on this one, or maybe 2 on this one. You can balance your load by moving virtual machines between the hosts. Also, if one of the hosts in the cluster crashes, the virtual machines can be reloaded on the other hosts, providing for fault tolerance and disaster recovery. The same is true with hardware maintenance. If we need to add memory or perhaps repair a disk drive or something on one of the computers, we can move the virtual machines to the other hosts in the cluster, bring down this computer, provide for the necessary upgrades, and then move the virtual machines back onto it once it's up and running. Another benefit of data center virtualization is it allows for the creation of software-defined data centers, SDDCs. And these software-defined data centers can then be plugged into a public cloud to extend the data center, provide specialized applications, as well as more disaster recovery. We'll be talking about the ways in which a software-defined data center can be extended into the cloud in Chapter 10. On page 16, we'll take a look at virtual desktop infrastructures. In a traditional environment, the personal computer runs its own operating system and applications, using either local data or perhaps data on the network. And this is referred to as a thick client. A thick client is one which has its own operating system and applications running on the personal computer. This can lead to additional support costs. When you have to upgrade an operating system version, you may have to physically go to multiple computers in different locations. It also limits mobility, since the user has to be at that client to perform certain tasks. A virtual desktop creates a more flexible environment by running a desktop as a virtual machine on a server. And then that virtual machine is accessed via a thin client. As shown in this diagram, we have the desktop running on the host in the data center. The user then has a thin client on their desktop system that connects to that virtual machine or virtual desktop. And the thin client is basically a terminal. All the actual work and computing and software is running on the virtual machine in the data center. Virtual desktops also provide us with more mobility, since the user could be running this thin client from home, and more device options, because you can also run a thin client from a tablet or possibly even a smartphone. Page 16 talks about the steps necessary and some of the components that make up virtual desktop infrastructure. Of course, first we need our host computers. These host computers have to have a virtualized data center hypervisor such as vSphere or Microsoft Hyper-V, which are Type 1 hypervisors. Then we also need to install the virtual desktop software such as VMware's Horizons. Next, we need to create the virtual desktop machines. So we'll install the operating system and then necessary applications onto the virtual machine. And then each virtual desktop has to run an agent called a VDI agent that allows it to connect to the thin client. Then we'll need to install thin clients on the different devices that will be accessing these desktops. And the last but not necessarily the least is the broker. The broker allows a connection to be made between the thin client and the assigned virtual desktop for that user. So the broker plays a very critical role in this process. Now, virtual desktops, if you have hundreds of users, each with their own virtualized desktop, can take up a lot of disk space. Quite a bit of that disk space is potentially redundant, because if 100 users are all using the same version of Windows, then we're repeating that Windows installation 100 different times on our virtual machines that are running in the host. This space utilization can be greatly decreased by using a concept called linked clones. With linked clones, we have a parent image that contains all the common software, like the Windows operating system and certain applications, perhaps like Office, all installed in that parent image. The linked clone then, that virtual machine, just has to have what's unique to that user's setup. So the linked clones can be very small by comparison, and this usage of linked clones really reduces disk space needed to implement virtual desktop infrastructures. In Chapter 9, you'll get some experience with two major virtual desktop infrastructure products. First, VMware Horizons, and then Microsoft's Enterprise Desktop Virtualization product. In addition to these commercial products, there are a number of open source infrastructure options as well. Oracle and Citrix both provide virtual desktop infrastructure products based on the Xen hypervisor. While we won't be covering these in Chapter 9, it's important to know that these options exist. Virtualization. In this type of environment, each application is allowed to have its own registry and file system. In that way, virtual applications do not leave any footprint in the host computer's registry or file system. They each run in their own container, if you will. And this concept of containers is becoming more and more popular, and especially used with Linux systems. Running applications in these containers allow multiple versions of the same software to run at a desktop environment simultaneously. For example, I could have Office 365 installed on a computer as well as Office 7, and the user could work with either product. Now, some of the application virtualization products that we talk about in the text include VMware ThinApp, Microsoft's AppV, and Altaris's Software Virtualization Solution, or SVS. Okay, that brings us to the end of Part 2. So, time for a break. I'll discuss cloud computing in Part 3.